Hello everyone, today we're going to be talking about the translations of the absolute value graph. So essentially what we're going to be doing today is we're going to be dealing with the parent function, the parent graph of y equals the absolute value of x. As we can see here, there is a rough sketch of this graph. And most of what we'll be doing in translations will be sketches as well. Okay, so essentially when we're dealing with translations, there are a couple of different things that we're going to talk about today. The first two things we'll talk about quickly are horizontal shifts and vertical shifts. All right, we're not going to deal with anything other than horizontal shifts and vertical shifts, so the shape of the graph that we're going to be dealing with for absolute value functions will always be the same. It will just be in a different spot in the coordinate planes. So regarding horizontal and vertical shifts, there's an excellent table in our online guide that I would like to walk you through quickly so we can get a good grasp of what a horizontal shift is and what a vertical shift is. So from our textbooks, we find this table here. And this is a really good table because it outlines all the possibilities we'll have for vertical and horizontal shifts. Okay? So looking at these top two situations up top, the scenarios up top, we have f of x plus a moves the graph to the left, f of x minus a moves the graph to the right. So essentially what this is telling us is that this is our horizontal shift. So when we see a problem, I'm going to write this in function notation, f of x equals the absolute value of x plus 3, right? What does that tell us? Well, all that tells us is that the graph is going to be shifted 3 units to the right. Essentially, we're looking at this scenario up top here. Okay, so the absolute value of x plus 3 is a graph that is shifted 3 units to the right. So here we have a horizontal shift. Okay, so the top two scenarios, f of x plus a or f of x minus a, moves the graph horizontally, which means to the left or to the right. So if we take a look at the absolute value of x plus 3, what does that do to the parent function? Well, if we take a look at our original graph, here we have the absolute value of x, right? If I want to have y equals the absolute value of x plus 3, right, I know that that is a horizontal shift 3 to the left. Right, so I'm going to take this one vertex point and I'm going to shift it 3 to the left. If I move this 3 to the left, the entire graph comes with it. Everything moves 3 to the left. So this right here is the y equals the absolute value of x plus 3. Okay, if I had y equals the absolute value of x minus 3, it would be a shift 3 to the right. Now let's take a look at the bottom two scenarios. We have f of x plus a and f of x minus a, these bottom two scenarios, right? They'll move the graph a units up or a units down. So essentially that's like saying something like this. F of x equals the absolute value of x plus 3, or the absolute value of x minus 3. And this is moving the graph up or down, so this would be a vertical shift 3 units up. So the vertical shift 3 units up, what does that do to the parent graph? Well, if we were to look again at our parent function, y equals the absolute value of x, and we were to change this equation right here to y equals the absolute value of x plus 3, okay, what happens? Well, this original starting point here, right, what's happening to that one point? Well, that point and every other point is being shifted up 3. So as I move this up 3, I'll have to move all these up 3 and all these up 3. So this is a vertical shift of the graph up 3. Okay? So whenever we see anything like these, we should first be able to tell what's going on to the graph. All right, so the ultimate goal of translations is not to have to create a table, list if x is 0, 1, 2, or 3, or -1, -2, -3, what do we get for y's? We'll have to plot all those points out. We should be able to look at the equation of an absolute value function and determine where the vertex is. Okay? So let's take a look at this equation here. There's a lot going on here. We're dealing with the absolute value of x plus 1 plus 4 equals f of x. So what's going on here? Right? One way we could graph this, we could create a table, we could plot each point out, right? Or we could use translations and what we already know. So let's take a look at this table. Okay? So here, right, this lists out all possibilities. So do we have anything that looks like this top thing right here? Do we have anything that looks like f of x plus a? Right? Does that, anything like that? Right? We're looking at it. Let's take a look at our equation. Well, here we have something like this. Right? What does that actually mean? That is a horizontal shift, right, HS, to the left 1. Okay, so we know that our original starting point is going to have to be shifted to the left 1. What else do we have here? Well, we also have something that looks like this, right? We have the absolute value of x plus another value. We have the absolute value of x plus 4. So what does this tell us? Well, this right here is a vertical shift, VS, up 4. Right? So what does this actually mean for our graph? Well, let's take a look. So whenever we have a graph, and we have translations being done to the graph, right, really the one point we're concerned about moving around is the vertex point, right? In the parent function y equals the absolute value of x, the vertex is at 0, 0. Now we're dealing with a different function. Now we're dealing with f of x equals the absolute value of x plus 1 plus 4. So what's going on here? We know two things. We know vertical shift up 4. So this point is going to be moved up 4. And it's going to be moved to the left 1. All right, so now this point, instead of being at 0, 0, is now at -1, 4. What happens to the rest of the graph? Well, the rest of the graph is exactly the same. So now this graph will look like this. Let's try another example. Let's take a look at this problem. So we have the absolute value of x minus 3. F of x equals absolute value of x minus 3 plus 2. Well, nothing really changes here. The numbers are different. Maybe the plus minus signs are different, but the strategy is exactly the same. Right? So here, one shortcut I've found when I'm doing these is if I look at a problem like this, right? If I look at a problem like this, I can tell where my vertical shift is and where my horizontal shifts are. Right? So here I know that this area is where I will find my vertical shift, my horizontal shift. Right? This area over here is where I will find my vertical shift. So knowing that, the problems become pretty simple. Right? So here I know my horizontal shift is right in here. There's my horizontal shift. The tricky thing here is you'd think that you would go to the left 3, but this is actually counterintuitive, right? So you go the opposite of that sign. So this tells us that we need to go to the right 3 because it's a minus sign. If it were plus 3, we'd go to the left. That's the only one where it's like that. The outside part is actually very straightforward. We see plus 2. This tells us we need to go up 2, right? So whenever you're looking at a translation problem, try to write out in words, or at least in abbreviations as I've done, what's actually happening to the graph. It gives you a good starting point to move forward and actually plot out the graph. All right, so what does this look like? What does a graph look like? Let's take a look. So here we know the starting point is going to start at 0, 0, right? The parent function graph, the starting point always 0, 0. And actually, when we look at these graphs, we can actually tell where the vertex point is just by looking at it, and we'll get to that in another minute or so. So starting here, right, what's happening? Well, we already wrote this out. We know it's got to go to the right 3, and we know it's got to go up 2. So we're going to move this 1 point, 1, 2, 3 to the right, and 1, 2, up 2. Right? The shape of the graph never changes. Never changes. So we're just going to sketch the final result, and there we have it. Right? How much faster is that than actually plotting out a table and listing out all the points? Much quicker, much more efficient. The last thing I want to talk to you folks about today is being able to identify the vertex just by looking at a graph. Right? Knowing where the vertex is can basically tell you how to graph it. So let's take a look. If we look at this equation right here, if we have a vertex at h comma k, and keep in mind, don't let h and k confuse you. All that means is that that's where the vertex is. H is a point as an x coordinate, k is a y coordinate. Right? So this is the vertex. Right? In an equation, we can look for the vertex as f of x equals x minus h plus k. So if I were to give you something like this, we should immediately be able to tell where the vertex is. Well, where's the vertex? Really quickly, we know that this is h, so h has got to be positive 4, k is going to be 5. Right? Now we have a starting point for a graph, and we can just draw the absolute value function from that point. Okay? So now that I've walked you through this, I would like you to do a few examples on your own before I give you these problems. First, I want you to list out what's happening to the graph. Second, I want you to graph it. All right? So process of listing out what's happening and then graphing it. Take a look at these problems. So once again, list out what's happening, find the vertex, list the vertex, and then ultimately graph. Okay, shouldn't take you too long. These are very straightforward. Are you going to be excellent at translating graphs right off the bat? Perhaps, perhaps not. Practice you'll improve. You'll be able to do these more quickly, and you'll ultimately feel more confident.